Welcome to video 4, the sampling concepts, procedures, and plant application. This should be it. I flipped ahead, I created these slides, I should know where I'm going, but yes, this is it. You guys finish up this one and you will be ready. So we're going to pick up where we left off. Before we were talking about some of your ignition source. So I left you with a fire. Now I got to figure out, hopefully you didn't burn down before I showed you how to respond to your fire. So this is what you do. Fire extinguishers. This is one slide. I could do a full half day or even a full day on fire response. But I'm only doing this in one slide. I'll have this up so you could read it. But I'll talk to you a little bit about it. Your fire response is where you definitely should pick the right extinguisher for the fire hazard that you have. And this comes from before you even have an incident. You should go through in the fire prevention plan, figure out this is our area that we're dealing with, here's the hazard, and if it's a fire hazard, this is the control mechanisms we need for this fire hazard. If it's an engineering control, you could make sure it's engineered out altogether so you don't have an issue. Is it a control with administrative or work rule, or is it PPE? That's something you have to wear. Now the fire response is something happens, you pick the right fire extinguisher. How do you use the fire extinguisher? And then this is where the slide comes in. Very brief. You're gonna pass, which is you're gonna pull the pin. You're gonna aim the nozzle. Then you're going to spray the agent into the base of the fire, and then you're going to sweep your nozzle from side to side, covering all of the fire, and you're starting from the base. So instead of spraying at the top of the crest of the fire, you want to make sure you get down to the base of the fire, and that's where you're going to sweep. Call for some help, and you're going to evaluate the system. If it's a structural fire, you got to get out, let the fire department take care of that. So a process fire or a small quick fire, if you're doing a welding project and after you finish welding, you should need 30 minutes of a fire watch. And if that welding facility is next to a lab, then you definitely have to make sure that fire watch is intact for 30 minutes. And if nothing happens, you're good. But after that 30 minutes or within that 30 minutes, a fire starts, grab your extinguisher, do that pass system, and then make sure that the fire is completely extinguished before you leave. Spill response. Again, I do an 8-hour class on spill response, and it's an 8-hour refresher class. So one slide is not covering the 8 hours. So I'm going to let you read the slide, and I'm going to talk to you about the basics. Spill control and spill response in a lab. Something spills and it's on the table. It's very quick to wipe it up, make sure you're using the right PPE to protect yourself, and then you're going to put it in an approved container, especially if it's a biohazard or some sort of chemical hazard that needs to be put in a special container. You do that. But let's say you have a big drum like in this picture, and you have a spill, pesticide, or a chemical solvent, then you may have to do a larger spill response. And any spillage you have to address it immediately. And the best thing to do if it's a large spill is barricade, just isolate the spill as best as you can. The picture showing you like a sandbag or some tubes that are spill. It's basically for spill protection, and it's keeping it all in one isolated area. And at that point, you have it isolated, and you have it centralized. It's easier to take care of the spill. So if there's a spill and you can't isolate it, then what happens is it keeps moving and moving and moving, and that spill gets larger and larger and larger, and then it becomes even harder to deal with. So you want to grab that spill as quickly as you can isolate it, contain it, and then absorb it, whatever that chemical is, with some absorbent pad. If you need to throw down some quick dry or kitty litter to absorb some of that liquid, that's what you do. And on your SDS sheets, they have a section specifically for cleanup. So review your SDS sheets, find out what you're dealing with, because if you're adding chemical to something that may have a flammable vapor, water activated flammable vapor, then you're doing the wrong thing, and that's not what you want. So get out there, grab that SDS as quickly as you can, and for the best way of doing a spill control plan is know what you're dealing with ahead of time. Do a job safety analysis before you even do your lab sample, so you know here's the hazards that are associated with this job. Here's what we're going to do if there's if one of those steps breaks down and we have an exposure. This is how we're going to fix that exposure, and that's your spill control. If it's a big enough spill, you may need someone that is qualified more than yourself, and you'll have to call them in. One slide on first aid procedure, and we went over some of that when we did the bloodborne pathogen. But if you have some vapors and you're not working under a hood where it's an exhaust hood that sucks out the air, then you need to get yourself into fresh air. If anything splashes in your face or your eyes, flush for at least 15 minutes. That's not just 15 seconds. You're flushing a good long time. Get it out of your eyes. Then your splash on your skin, you're going to wash your skin with soap and water. And if you ingest any liquid, or if you're working with someone that ingested any kind of hazardous material, grab that SDS, and what you're going to do is you're going to find out what that says. And with that SDS, it's going to be exactly what you need. It'll tell you in order for you to treat that person quickly and effectively. And call 911 if it gets one of those spills or cleanup that you need bigger help. You're going to call 911. PPE, we've gone through this in several different ways, so you know to protect yourself. And if you're choosing PPE, you should have a hazard assessment for the PPE that you choose. So it may not be good to say I need gloves. A hazard assessment is going to show you exactly what that gloves is. If you need latex gloves, if you need puncture resistance gloves. So do a hazard assessment. And the General Industry 1910 rules under the PPE section says that you have to have a certified PPE hazard assessment. So if you don't have that, then you have to take another step back in the lab and make sure you do a certified hazard assessment. And if you need help, I could do that as well for you. GHS labeling. We're going back to the GHS after those 3 quick slides. Now we're going to go and finish up the rest of this portion with your new labeling. This is what the labels are going to look like when you get them. On top will be your identifier. It'll tell you if it's flammable. This one is ethyl alcohol and methanol. So it's telling you what it is. That's your identifier. Then it's your signal word, which is danger or warning. Those are your 2 signal words. So it gives you your signal words, and then it's going to show you a picture. And that pictogram is replacing the NFPA symbol, which is the National Fire Prevention Association, and HIMS is Hazard Identification Material Signal Symbol. Those 2 symbols are gone. They're going to be now the GHS symbols. Then after your pictograms, you're going to see your hazard statement. And this one is telling you that it's a highly flammable liquid and vapor, and it causes severe skin damage, skin burn, and eye damage, and then so on and so forth with your hazard statement. And after your hazard statement has 3 precautionary statements. One is prevention, one is response, one is storage and disposal. And then at the end of your labeling, you'll have the manufacturer information. All your GHS labels are going to look the same in this order. So you won't have one where it gives you your identifier and then right after it'll give you the manufacturer information, because that is not GHS compliant. So your GHS compliant labels will have these components in that order for every chemical you get. Danger and warning. Danger, more severe, and you know why? Because you looked at that scale we had earlier in video number 3, so you know about the scaling system. And then the warning, it's less severe hazard, but it's still something that could be damaging. It's an exposure. Precautionary statements include words and things with prevention, response, and storage. That's all in your precautionary statements. And here are your new pictograms. The one on the left, starting in the top left, I'll use my mouse here. That one is explosive. That's showing you some movement. It's explosive, self-reacted, organic peroxides. This one here is a gas under pressure. So that's supposed to be a picture of a gas cylinder, not a paddle. Or someone else had mentioned before that it looked like a rolling pin. But now that is your gas under pressure. This is your flammability. Pyrophoric might be under this. This one is an oxidizer, so you can see this difference between the O and the line. So that O in the line means it's an oxidizer. Acute toxicity, that's your skull and crossbone. It's fatal or toxic. Skin corrosiveness is your next one. If something drops on your skin, it could be corrosive to your skin. This is a health hazard. And this one over here is an irritant or a skin, something that's a skin sensitizer. And this is aquatic toxicity. So you see the dead fish on that side and the dead tree. That's telling you that whatever chemical that is toxic to aquatic life. Your secondary containers, meaning you get something from the lab, you got your nice big box that came in, and you want to break down this big buffer solution from the big gallon or 2 gallons into something smaller that you can handle. Then you have to also label those things. And your secondary, that's called a secondary container. So now your secondary container, and the 1910 1200 F6, that's your general industry standard for OSHA, and that's 1200 HAZCOM section F6. It says the employer shall ensure that each each container of hazardous chemical in the workplace is labeled, tagged, or marked. So first of all, before they tell you tagged or marked how, it's telling you that if you have it, the container, you have to mark it. And this is what it has to say. A GHS label. And it gives you the breakdown of the GHS label. And in doing so, you have to make sure this information is immediately available to your employees under this HAZCOM program. Now, the one on the bottom right is what you're used to seeing with the the F National Fire Pollution Association symbol, but that is now going to be changed to your GHS symbol on the top left. Now, where it says either this or this on the slide means as a secondary container, your place of employment has the choice of choosing one of those 2 labels. You can have the GHS label or the other label. So, but going back to this slide, you'll have to make sure the employees are provided specific information regarding the health hazards or the physical hazards associated with the chemical. So either one of those labels you got to use. Now these labels here, well, that's a benzene label in 2 different types. Those aren't the GHS labels, but as a secondary container, you could still use those as long as your employees are trained on both the old system and the new system. Here's some other labeling that is definitely not GHS compliant, and they're only telling you that there's a danger. It's showing you your PPE on one side, and it's giving you a PPE pictogram, but that's just basically for a smaller container. But again, that's not GHS compliant, but it's okay if it's a secondary container and your employees are trained on both. Here are the different things you have on your left, your NFPA, and then on your right, you have your GHS. This slide is making it where you can't really see that, so what I'm going to do here on the fly, I'm going to just adjust it a little so you guys can make it out a little better. And I'm going to highlight this. I'm going to put it in white, and being in white, you'll be able to see it a lot better. So this is a lot better for me to be able to do this than just run a PowerPoint for you, and if this showed up, you never would have been able to see it or know the difference. So here's my adjustment on the fly. Here's your categories. One is the severity, and you know why, because it's looking at that scale of either milligrams or the scale of Celsius, and the lower it is in milligrams or the lower temperature it takes to react is your category 1 or 2, and that's where it's showing you your GHS nomenclature versus your NFPA, so it's completely flipped from before. We'll move into the SDS. So your SDS, safety data sheets, no more flexibility in the format, it's going to be rigid. All the things that are classified as either a health hazard or a physical hazard are based on the same GHS criteria. And then on Appendix D, and that's Appendix D of the 1910-1200, it specifies the minimum information which is included in the 16 sections of the SDS. I'll put that up all at once so you can see it. And this is what all the SDS are going to look like. It'll be developed or obtained for each hazardous chemicals. They'll all be in English. Have 16 mandated sections. Cannot have any blank sections. Be maintained in the workplace and be readily available to the employees. That's what the standard is saying that you have to have. Number 1 is always going to be the identifier, the emergency number. Always be section 1 of your SDS out of the 16 sections. Number 2 will always be the hazard identification. They'll give you your signal words, and then the HNOC means hazards not otherwise classified. So there's some hazards that don't have a specific classification yet, so they'll say HNOC. Pyrofluoric gases is one of those. Those are gases that can spontaneously explode in the presence of oxygen. So that's one of them that are hazards not otherwise classified. Combustible dust, the same thing. That's a HNOC. And you'll also see your mixtures and whatever comments in the hazard 2. 3, composition. What's the makeup of the ingredients of the chemicals? The name, the common name, the CAS number, that's the classification number, and the whatever percent of chemical it's in, cutoff limits, all that composition that makes up the chemical will be in 3. Whenever you're doing your hazard communication training, and this has to be done annually, and with the GHS changes, it should be done now, first aid will always be section 4. Let me take a little sip there. Today I'm drinking herbal tea, yerba mate tea, so it's helping out my voice. First aid measures, that's always going to be in section 4. Anything happens, and you need to grab a SDS sheets very quickly, grab it, go to section 4, and you'll know that that's your first aid measures. A fire comes out, you're grabbing that SDS, you're going to look at section 5, and it'll always be for firefighting measures. And that's the great thing about the new SDS sheets. Accidental release and what PPEs you need. That's going to be in section 6. Some of these will have pictograms, so you can actually see a picture of a guy wearing goggles, and I'll let you know that, hey, I need to wear goggles. The handling and storage, that's in 7. 8 is your exposure control and your personal protection. Again, that gives you some of the other PEL, which is permissible exposure limits and threshold limit values. That's what you're getting in this section. So it'll let you know in an 8-hour period, this is what I could be exposed to without it being a physical or health hazard. And, your physical chemical properties of the chemical is going to be on 9. That's your flash point, your lower explosion limit, your upper explosive limits. That's all going to be there. Stability, reactivity in 10. 11 is the toxicology information. And these last 5, 12 to 16, they're not mandatory under OSHA because OSHA doesn't deal with ecological information, the disposal, transportation, data preparation. Those things are not regulated under OSHA. OSHA is looking for material that's pertinent to worker safety. Use and safe practices of some of these flammable and combustible materials. So you want to make sure that no open flames, welding, keep things away from direct sunlight, well ventilated area, store the oxidizer separately than the flammables, and if you have 2 different type of materials in the same cabinet, it's got to have that half-hour fire resistance. And the key thing to remember, go through that, and we kind of just went over that. Now, at the end of this, while I'm going through, these are some of the people who I talked to help put this presentation together. I asked them a question saying, it was several questions, and one of the questions was, if you had a tip for laboratory professionals, what would your tip be? So McCoy Hill, at the time of my question, and this was probably early 2000s when I first made this presentation, and he was City of Orlando employee at an Iron Bridge facility, and he says the quality of the sampling program, like most things, is only as good as its weakest point. So, meaning, if you don't have a good sampling plan, that's your weak point, and it's going to come back to haunt you. Or if you have a new employee that hasn't been trained very well, that's your weakest point. So that's what that statement is. A good sampling program is choosing the correct sample point for that sample. It's very important. You got to choose exactly where it should be for the representative sample. If you're saying you want it at this location, then you're going to have to figure out what depth of sample you're going to take. If you want it a foot down from the water, you want it half of the tank dimensions, however you word it, put that in the sampling program. And the location where the flow is well mixed and consistent. Don't go to that dead spot in the tank just because it's easier to reach. You may have to adapt some sort of extension on your pole or build some sort of way to reach the most representative sample in that tank. I'll give you the last 2 that he has. It says it should be free of floating matter and deep enough to avoid taking material from deep enough, but still avoid taking material from the bottom. So you're looking at middle of the tank, if at all possible, or at least a good 2 feet down. Location should be it should be accessed without risk to the operator. You don't want to create a hazard trying to get a sample, so the operator has to be free of that. The next is tips from Vincent Wright. Now, Vincent Wright, I call him Vinny, used to work together at Seacoast Utility Authority. That one is in Palm Beach Gardens, Florida. And he says these are some of the common interferences with the nitrates. If the nitrate sample that you're taking has barium at 1 milligrams per liter, it's going to interfere with your nitrate sample. Chloride at 1,000 mLs or higher is going to interfere with your nitrate. Copper causes positive interference at all levels. If there's any copper in your sample and you're trying to test for nitrates, then it's going to give you a false reading on your nitrates. Nitrite at a concentration greater than 12 milligrams per liter is going to affect your nitrate sample. And that's easy because easy to understand because your nitrites is very unstable. It's going to want to either denitrify, and it's going to give up its nitrate or nitrogen, and the oxygen now is going to look for a bond, and it's going to bond to another nitrite and make it nitrate, NO2 to NO3, and that's where you're going to get a false reading. So your nitrates at a certain concentration, the nitrites, at a certain concentration will affect your nitrates. Vinny on the chlorine interference says that chlorine, direct sunlight, that's going to affect it. Temperature goes up, chlorine residual goes down. Run the chlorine sample within 5 minutes of the grab, and we mentioned that in the beginning of our conversation, of our presentation, which was video 1. And Lorene Bachman, who I worked with at Wildpine Laboratory, Lorene says chain of custody sheets are very important. If the chain of custody has a broken link, then the sample is invalidated, meaning if there's a period of time where the sample does not have a location, either it's a period of time that it was released in from one operator, but then the laboratory the laboratory person that's going to run the sample could see a lapse from when they get it, and they know it wasn't in the refrigerator, then that could invalidate the sample. What happened to it during that time period? Quality control of handling samples are important. Observe holding times, preservatives, and sampling containers. It's very important if you're doing a test grab for fecal coliform and you have the sodium thiazole tablet in your container, but that preservative is either defective or missing, and you're putting it in you're taking your fecal coliform sample and there's a presence of chlorine, it's not going to be neutralized, so that chlorine is going to affect your sample. And here's my thanks for some people that helped me when I was creating this. Tom Vaughn of Waxahachie River District, Seacoast Utilities, Rim Bishop, who was the director and executive director of Seacoast Utility, probably still is, Roy Pelletier, who is a mentor and a friend, and all the laboratory professionals that answered my questions and provided some tips for the course. So I want to thank you for those. While I'm thanking you, I'm putting up some of my references that I used, including some materials from OSHA. So these are some of the places that I've got my material for the sampling for. And I want to thank you again for taking this course. You're going to have an exam at the end of this course, and once your exam is passed, we'll get you your certificate so you can show that you've taken this course. And if you need water, wastewater, or distribution CEUs, make sure that you also give me your CEUs, your license information, so I could make sure you get your CEUs. And you could reach me at sheldon@utilitycompliance.com. That is sheldon@utilitycompliance.com. And my office number is 888-398-0120. That's 398-0120. I'll do your sampling plan. I do OSHA compliance, 10-hour, 30-hour general industry and construction classes, and those do count for water, wastewater, and distribution system CEUs in the state of Florida. And I'm reaching out to other states to get those approved for water and wastewater CEUs. I do industrial pretreatment services, and that is local limits development. If you don't have an industrial pretreatment plan or program, I do that as well. I do risk management services. So if you have gas chlorine, anhydrous ammonia, sodium sulfur dioxide on your plant in a large enough quantity that you have a risk management plan, I do that as well. I'll do the full risk management plan for you. If you're a new facility, I'll deregulate your facility if you need that service. Or the 3-year audit. Can't forget that. Every 3 years after your 5-year resubmit, you're going to have an audit of your system, and I do that as well. So I'd like to thank you for your time, and we will get you in your next course. Have a great day.